more kilometers. Are there questions?
Yep.
I have time for one question.
Yep.
When you plan start with the operational NRAN network?
NLR network?
Yeah.
Okay, I thought you said Enron, and that has a certain connotation in the United States. NLR is hoped to be operational by late year. There are certain paths that are required for the TerraGrid, in particular to get to Pittsburgh. And I think we're hopeful. We're working on implementation schedules right now, but we're hopeful by fourth quarter of this year.
Okay. Thanks very much.
Okay,
thanks for coming all this way to tell this interesting story. I think
Thank you.
we can again learn a lot. Thanks again. Okay, the last speaker is Erik from SURFnet in the Netherlands, and he's responsible for the optical networking in Amsterdam, for instance, the experimental optical internet exchange. So he will say something about the experience of the networking within the Netherlands.
Yes.
Success, Erik.
Well, I hope I can get all your attention again after all this lots of information. I think it will be a bit of an overload already. But before I let you go for the break, I'm going to talk about NetherLight, an optical testbed, optical internet exchange that we're building in Amsterdam. And I'm just going to use the keyboard, I think, or let's see how this works. So NetherLight, what is it? I didn't give a presentation about this topic at the Torino conference yet, so this is the first time you'll officially hear about it. And how it is evolving since 2001 when we started this as a first wavelength service, an OC48 testbed. National International Lambda connectivity that's currently available and what we are going to do with it and what the research is currently done. NetherLight is not part of the production network of SURFnet. It is a separate optical testbed facility, and we call it an optical internet exchange, because we want to do high bit rate IP traffic. We want to transport high bit rate IP, but we do it by provisioning light paths, by provisioning end-to-end circuits over an optical infrastructure. And we also, well, this was mainly inspired by the building out of Starlight in Chicago, that is doing similar things, and together with people from Canada, from CANet 4. These were, kind of our inspirations for building this in Amsterdam as well. And what we also ask everybody is to bring in their Lambda into Amsterdam and to build out this network with us. If you want to know what you see on your network, then you can see that there's several types of users on your IP network. At least that's what an NRN is typically seeing. Professor Kees de Laat from the University of Amsterdam has made this broad category, and I think it's very illustrating. What you see is that you have many, so that's the number of users here on the, let's see how this works. Oh yeah. There's lots of users here on the network. That is, what did I do here? Okay, well. Oh, that's something in the bottom, isn't it?
Just click anywhere. Click anywhere, and then it's okay.
Oh, yeah, there it is. Okay, thanks.
So it is in the middle.
Mm-hmm. Okay, let's try it again. Anyway, what you see here is, then I want to go back again. Okay. It's very advanced, too advanced for me. What you see is three types of services, three types of users on your network. It's the A class that has a maximum of about ADSL connectivity. That's about, a few megabits maximum. And they want to do everything on the network. They will want to have, they want to browse to email. We call them lightweight users. There's a lot of those as well on the NRN network, of course. Lots of home users of the network. There's a large community of business users of the network that is interested in having multicast access, wants to do streaming applications, VPNs, mostly at their offices and in local area network up to a gigabit, what we see now in local area networks. There is a last class, class C, that is coming up more and more, that demands special access to the network, has very high demands on the network, high bitrate computing, data grids, and virtual presence. All these want to have lots more traffic. But as you see here, the class A will need full internet routing. So it's one-to-many locations on the internet. B is more like VPN type of connectivity, does need full internet routing, but the C category needs mainly very big pipes that are few-to-few connectivity. It's not full routing involved here. What you also see is the total bandwidth that will need on your network is that this class C might flood away all your other traffic on your network, while the majority of the users plus this LAN users will both, make moderate use of this network. And by going into optical networking space and making laptop provisioning, we especially want to target this class C type of users. And then we can also offload it from the regular network. So that is partly summarized here. As we see, also the rationale for this NetherLight testbed is giving the scientists, as they talk to us, a relief for the need of high bandwidth point-to-point connectivity. At the moment, at 1 gigabit per second, typically what we see. We also see 10 gigabits demands for the near future. They want low jitter, low latency, but they don't need the capacity all the time, so we can schedule it around depending on when they have their projects, when they have their test beds in place. Well, for a provider like SURFnet, this means that if possible, you want to keep this out of your expensive backbone routers, if possible. But what you also see is that when you acquire wavelengths, dark fiber in your network, that you will have a lot of bandwidth available for this use, so that's a good opportunity there. But we, as said before, we don't see backbone routers at this moment to be able to scale, also in the near future. That we should keep this traffic as out of the IP layer as if possible. And we see a challenge here to have a common control plane for all of this network in one network in the future. So NetherLight is still a test bed, but we want to get ideas how we can use it for the next generation of the SURFnet backbone. We don't want to do this alone, so NetherLight is directly coupled to a lot of locations and entities in Europe and in the United States and in Americas. Starlight, a canary in Canada, CERN in Geneva, CESNET in Prague, and there are others. It's real and international venture. In late 2001, we started with a 2.5 gig wavelength between Chicago, the Starlight facility, and Amsterdam. This was purely for research purposes. What we did is we put Cisco ONS 15454 and equipment at both sides that has, well, of course, 2.5 gig POS framing towards this wavelength, and at the local area network side, there's gigabit Ethernet frames, gigabit Ethernet interfaces. And there were computer clusters at both sides experimenting with long-distance TCP experiments and doing all kinds of things. So there was not it's not really optical capacity, but it is gigabit Ethernet, non-routed, layer 1 capacity available. In 2002, there was the iGrid 2002 event that you might have heard about. There was a lot of interest from the industry to be visible at that event, and lots of capacity was pouring into Amsterdam. And the network by that time consisted of this structure here. We had New York connected so Abilene had a connection into Amsterdam using a 10 gigabit line that was offered by the IEEEF or IEEEF or something like that. IEAF that uses a Tyco facility in all over the world, and there was this link was one of the first that was made available. Level 3 gave us during the event even an additional 10 gigabit link into Starlight. So we had our own 2.5 gig link. We had a 2.5 gig capability to get into CERN, to the high energy folks there. CERN had their own 2.5 gig data tag link into Starlight as well. And for the astronomy folks, the Astron Jive people, we had built dark fiber with DWDM capabilities from SURFnet to assist in getting all these radio telescope data into Dwingelo. Well, let's try this again. One of the things that was happening during iGrid was a light path trial, so a non-routed IP transport between Vancouver all the way down here in Canada, using 2 times gigabit Ethernet circuits, non-routed into Starlight by Canary, and then SURFnet brought it back to Amsterdam and then into CERN. And there was maybe one router in this path, maybe at the end, I think, or at the beginning, but certainly not in between. And they used it to transport a terabyte of data. I think it was on the next slide. No, it's not. So, anyway. Okay. Well, I think that there was some presentations by Wade Hong and others, yeah. So they transferred about a terabyte of data in real data, and that was equivalent to a full CD in about 8 seconds and a DVD in 1 minute. They used all kinds of BBFTP, all kinds of grid type of data transport protocols to make this possible. And it didn't overload the IP network at all. So that was good for us. And they use this type of trials to do data replication between the Triumph high energy physics cluster and the CERN high energy cluster. They want to do that real time in the near future. So we want to, experiment using light paths for this type of research. At the moment, this is the list of current wavelength services coming into NetherLight at the moment. Well, the Jive Institute is connected using, we installed a 32 lambda system that transport gigabit Ethernet channels at the moment that can be upgraded to other line speeds, this is especially for the upcoming radio astronomy data collection into Dwingelo. They have their data correlator system there, so they want to connect all kind of radio telescopes real time with this facility. Well, there's a couple of wavelengths, 10 gigabits to Starlight, to CERN, and to New York, and we'll have 10 gig to Starlight and Stockholm and UK Light coming up. Okay. You see a couple of names of lights in this picture. We see that all these facilities are separate from the IP network, and they're all kind of light named. And so the UK is coming up with UK Light here. Oh, it's not. Oh, yeah, here. I think they will be online by the end of 2003. Well, Starlight is, of course, in Chicago, NetherLight in Amsterdam, and the Czechs have Czech Light in Prague. And, well, this is the emerging lambda grid as we as we see it happening in Europe today. Geneva is mainly the CERN facility that's connected with 10 gigabits to SURFnet at the moment. Research activities now are mainly to get a good use of all this lambda capacity to define the right architectures, how to put IP traffic onto these networks. We want to switch all this optical capacity in Amsterdam in this main cross connection point. There will be an optical switch matrix installed in Amsterdam, and this has to be controlled using GMPLS or other types of protocols available. But this is all. We see that the industry really has to do with a lot of work for this lambda provisioning. But this will be part of the work done on this testbed. And of course, as we saw before, the data transport testing on this network should be done with networking groups doing high bandwidth experiments, for example, high energy physicists and astronomers, for example, in the VLBI network in Europe. Let's see. Well, we see this as a kind of a paradigm shift. This word has been used a lot in optical networking. But I think it is really true that by building all these optical networking facilities, the users are also appreciating this type of dedicated high bandwidth point-to-point capacities for their applications. And they are gradually improving their TCP stacks and all types of high bandwidth applications to make use of this type of new capacity that is new to build it and very new to control it, but it looks very promising in seeing how this will bring the internet further. What we also think is that while the industry might be in a bit of a slowdown, you can still start doing it and see what you can do with equipment that's currently available. For example, the equipment that I just mentioned, this Cisco ONS 15454, it is mainly a Metro Sonnet MUX. It's nothing fancy about that, but we put it in the network maybe in a different way than it was designed for. This is the way to work at the moment when doing optical networking. Let's see. That's all for now. Thanks for your attention.
Okay, thank you. Thanks very much, Erik, for this enlightening talk about the European light. Are there questions to Erik?
Not really.
Is everybody really longing for the coffee?
I think so.
Yeah.
I think he said everything.
Okay.
I want to thank still silent.
Sorry.
Okay.
I want to thank everybody for being here and hearing these interesting stories from everybody, not only in Europe but also in America. Thanks again for your.
3:30.
Supporting.